Okay, so we're going to have a look at 7b now from stats. You should make sure that you can complete that starter question there, please. So this tests understanding of the previous chapter before, and it's going to be really important for today's lesson. Okay, so some key ideas. When you have inequalities, it's often a good idea to list out what they actually mean. Okay, and then that actually lets you use the inequality sign this way around, because remember, that's what the calculator does. Okay, we're returning to a pretty familiar situation, which is about flipping coins. And our test statistic here is the number of times that it lands. Heads facing up, as before. And here you go. So it's pretty unlikely for 0 and 1. It gets more and more likely towards the middle, because what do you expect? Well, you kind of expect that H0 is that probability is a half. Let's go like that. And then you can see that it goes down and down and down again. So it sort of follows this curve shape. So if you got 8 out of 8 tails, that would be quite suspicious. What about 7? Well, 7 here is in red, but it would be good to know why the line is drawn at 7 and why it's not drawn at 6. So 7 is what's called a critical value, okay? Because 7, we know, causes us to think that this one is wrong and to accept an alternative hypothesis. So we'll look at why it's at 7. As a whole, you could actually say that 7 onwards, this is a critical region. Okay, so it's useful to talk about regions and values. You might remember last lesson and from the start of today, our calculators are sort of work on the idea of regions, okay, because it's about cumulative probabilities. It's about adding the value and the more extreme values together. So what would lead us to think that it was biased towards heads and reject that it was unbiased? Here, a value of 7 or more. 7 or more, the critical region, 7, the critical value. Okay. Just another note here. So it says the probability of getting exactly 5 heads, which is the most, well, not the most likely, the second most likely result, it's only 22%. In other words, it's more likely to not happen than happen. So what's the point of this here? Is it saying it's not useful to look at the probability of one result alone? You need to have a look at the result of regions. That's what's important. So same situation again. So, H0 probability is 0.5. H1 probability is greater because he says it's biased towards landing heads. He tosses the thing 8 times, so that's your 8. Okay, it means n equals 8, and counts the number of times that it lands. What values would cause his hypothesis to be rejected if the significance level is 5%? Okay, so let's have a go at this question here. What values would make us think, the coin is biased? Well, 7 and 8 seems to be what the previous slide said. So let's try and work out why that is. Okay, so even a value like 6, which you might think is quite unlikely, the region that it's part of might mean that it's not something that would cause you to say that it's biased. So what's the probability that we would see 6 heads or an even more extreme value? And is this sufficiently unlikely enough? So is it rare enough to say that the coin is biased? Well, what we could do is we could use this cumulative binomial sort of distribution table here. And you can get this from the back of your book, but this is in your calculator as well. So how do we read this? This is the probability of x being less than or equal to 0. In other words, just 0. This is the probability of x being less than or equal to 1. So it's adding these numbers up as you go. So if we counted 0 to 4, for example, 0 to 4, the probability attached if you add up 0 to 4 is 0.63. So in other words, 0 up to and including 4 is 0.63. So this represents 63% of the probability. Well, if you remember last lesson, if you want the red part to be less than 10%, that was the significance level for that question, that would mean that the blue part needs to be more than 90%, doesn't it? So we're looking, which value do we go up to so that this whole area here, so that it's more than 90%? Because probabilities only add up to 1, that would mean that the red area would be less than, wouldn't it? It would be less than 10%. Well, what if you go up to 5? If you go up to 5, that's 85% of the data. So that's not enough because that still leaves about 15%. If you go up to 6, that covers 96% of the data. In other words, what's left over is very unlikely to happen. If this is 96%, what's the probability of these? Well, it's 1 minus this number here, isn't it? Okay, so what's that going to be? 0.035, something like that. It's a very small number. Okay, it's certainly smaller than 10%. So let's go through it. What's the probability that we would see 6? What's the probability that you would see 6 or a more extreme value? Well, 6 or a more extreme value is everything below the 5. So it's about 15%. Okay, 15% is not small enough to be less than the significance level. I apologize. Sorry, it was 5%, not 10%. Okay. So what about 7 or a more extreme value? Well, if you want 7 or a more extreme value, remember from the previous chapter, the probability of at least a 7 is the same as 1 minus the probability of up to and including a 6. This is just putting into words what we were doing over here. Okay, so if we did this, probability of 7 or more is 1 minus the probability of, up to and including the one before. It's smaller, so it's very, very unlikely. So 7 is a critical value because it's the first value that makes you think, oh, I would reject the hypothesis. That's the big idea. So in general, we could say, matching to the diagram that we had before, which was, all like this, we sort of turned it onto its side, okay? And this is what it looks like. So 7 or more makes the area of the 7 or more part less than 5%. In other words, it's the first point where you would reject the null hypothesis. So the critical region is the range of values that would lead to you rejecting the thing here. So in that case, it's 7 or more. 7 or more is the stuff that's in red. Okay. The value at the boundary is the critical value. So 7 is the first number, the critical value that would cause you to reject it. There is a shortcut attached to this, which is when you look at these numbers here, you can use the first value after the one that exceeds 95%. So what's the first one that goes above 95%? So it's 6. So the one after that is 7. Okay, this is a shortcut that you can use. Why does it work? It works because of how you find the probability of 7 or more. Yeah, that's 1 minus the probability of the thing before. That's why this method works. Okay. So some quick fire questions, and they're all based around a 5% significance level. So, what's the critical value? What's the critical region for these things here? And these probabilities have been worked out for us. Okay. So X is still going to be heads. So where does the probability of the thing being that or a more extreme value, where is it less than 5% for the first time? So let's try an example. So if you tried, let's say 3, is the probability of 3 or more, is that extreme enough? Well, 3 or more So how do you get 3 or more? You do 1 minus the probability of up to and including the number before. So the probability of 3 or more is 1 minus the probability of up to 2, which is a half. So it's only a half, 0.5. Well, 0.5 is definitely not less than 5%. So you need to keep going. You need to go further down the table. Let's try 4. What's the probability? What's the probability if we talk about 4 or more? Well, it's 1 minus the probability of up to and including 3. 3 is 0.81, so that would only be about 19%. So again, it's not unlikely enough. So you've got to keep going. And what you will find, this is actually the first value that's not on the table. If you talk about 5 or more, it means 1 minus the thing before. 1 minus 0.96 is about 0.03. That's the first value that would be less than 0.05. Okay? Or if you like, it's the first number after the one that's above 95%. That's another way you can do it. So let's try that as a quick method. The first value after the 95% one. Well, this is before 95. So this is the first value that goes past 95. So then you pick the next one. Okay, and just so you can see that it works, the probability of greater than or equal to 9 is 1 minus the probability of up to and including 8. Up to and including 8 is 0.98. So this will give you a value of about 0.01. It's about 0.01. If you try for yourself, pause the video quickly if you like, try it for greater than or equal to 8, and you'll see that it doesn't work. It will give you about 5.5%, which is too big. So 9 is the start of the critical region. 9 is the critical value. The region is greater than or equal to 9. Okay. And the last question kind of flips the thing around on its head, literally. So it says, what if the thing is biased towards tails? So biased towards tails. If we go back to our diagram, in other words, we're looking at the left-hand side now, and we want the first number so that all of these together is less than 0.05. Well, where's that? Let's try 2, for example. If you go 0, 1, and up to 2, you get 0.054. It's actually too big. What about 1? That's 1% and a bit. So that's definitely less than 5%. So in other words, 1, or more extreme than 1 would be 0. This is your critical region. Whereas all of the blues would be okay. It's because instead of talking about heads, you talked about tails. So it sort of works the other way around. You'll notice that this one was much easier. You just look for the first number that's less than 5%. Okay? So these are critical regions, and you can do the very difficult parts of the chapter using this method that come later in 7C and 7D. We've got just a few more things to talk about. So let's talk about actual significance level. So we've talked about making the probability of a group less than 5%, but you can actually say what it actually is. So for example, if I talk about the probability of being greater than or equal to 7, if I talk about these probabilities, well, how do you get the probability of greater than or equal to 7? Well, you do 1 minus the thing before. So 1 minus the probability of up to and including 6 is 1 minus 0.9648, and it's 0.0351, something like that. In other words, the probability of having a 7 or more is, what's that? It's about 3.5%. That's the actual significance level, okay? The actual significance level is how much probability it actually makes up. So sometimes you might be asked to work this out. And as a final question, let's do this one as a final question. So one more element that we can do also is we can talk about a two-tailed test. So So far, we talked about, the probability is 0.5, and then the question had an inequality like this or like this. Yeah? This is called a one-tail test. You examine one end, yeah, like this. You examine just the right-hand side, just one end of the thing. If you're going to do a two-tail test, though, you examine both ends. You would examine the left and the right in the same test. The probability would look different as well, because you're looking for, is it greater than 0.5? Is it less than 0.5? In other words, your alternative hypothesis would look like this. So how do we handle these situations? Well, the good news is it's almost exactly the same. The only thing that we need to do, if it's two-tail, is we need to take our significance level and we need to split it. We need to split it to the left-hand side and to the right-hand side. In other words, we're going to divide it by 2. So instead of talking about 5% now, we're going to be talking about 2.5%. Okay? So what are the critical regions so that 2.5% is the thing that you have to be less than? Well, 2.5%, let's have a look at the table. So let's have a look at the low end first. 0 is definitely less than 2.5%. Okay, up to 1 is 3%, so now it's too big, isn't it? So the critical region for the low end, the negative tail, is actually x equals 0. It's only this result here. Okay, this is for the low end, or the negative tail, if you like. What's the value for the big end? Well, the shortcut is, think about 2.5%, so take that away, so 97.5%. Find the first value after 97.5%, okay? And then the one after that. That's the shortcut that we talked about. So what's the first value after 97.5%? Well, it's this one. So that goes to a 7. So the value after that is an 8. So the critical regions here are actually the same as critical values because there's only one thing. So a 0 or an 8 would cause you to reject the null hypothesis and accept the alternative. And anything between a 1 and 7, as it said, means that you accept the default. There's not enough evidence to suggest that anything is going on. So the main idea, when it's a two-tailed test, divide the significance level by 2 and handle it as 2 separate questions.